Hi, my dear students and respected viewers. Please subscribe my channel. Okay. Now I am explaining one of the important concept in probability. That is various definitions of probability. Right. This is the one of the main important question in your examinations. And so, what is that? So there are mainly three definitions of probability in probability. The three definitions are: first definition is called mathematical definition of probability, and second definition is called statistical definition of probability, and third definition is called axioms of the probability. Well, there are three types of definitions. Okay, so now one by one discuss the definitions. So the first definition, right? The first definition is mathematical, right? Mathematical or the other name is that priori or classical, right? Classical definition. Okay, this is the first definition. What is that? Mathematical or priori or classical definition of probability. What is that? So now you have conducted trial, or you can take any type of random experiment, or if a trial is conducted, or maybe if a trial is conducts, there are the n events is there. If a trial conducts, there are n events, right? But trial conduct, there are n events. The events are exhaustive. The events are exhaustive and mutually exclusive. Mutually exclusive, and third one is got equally likely. That if a trial conducts, there are n events. The events are exhaustive events. Okay, and next one, exhaustive means total number of possible outcomes in any random experiment is called exhaustive events. So any experiment give the exhaustive events. Okay, so the events are exhaustive, and the next one is mutually exclusive events. What is mutual exclusive events? If the occurrence of the one of the event, the other events are precludes, and it is called mutually exclusive events. Okay, next one is equally likely. Equally likely means if we conduct any random experiment, the events are equally chance in the outcomes are in equally chance there. That is called equally likely events, right? So if a trial conduct, there are n events. Exhaustive events are exhaustive, mutually exclusive, and equally likely. Okay, so now equally likely events, and the important concept is m, and m of them are favorable. M of them are favorable events, favorable cases, or maybe none of them they are favorable to an event A. None of them are favorable to an event A. Is in another event, them are favorable to an event A. Then the probability of the occurrence of event A, then the probability of the occurrence of the event A, then P of A is equal to, the formula is P of A is equal to the ratio of favorable cases, the ratio of favorable cases to the exhaustive cases, favorable cases to the exhaustive cases is called mathematical or priori or classical definition of probability. The definition: if a trial conducts, there are n events. The events are exhaustive, mutually exclusive, and equally likely events. and m of them are favorable to an event A, then the probability of the occurrence of the event, okay, the probability of the occurrence of the event P of A is defined as P of A is equal to the ratio of favorable cases to the against two cases is called mathematical or priori or classical definition of probability. Symbolically is equal to m by n, say right, m by n formula. Okay, the prior definition was given by Laplace. The scientist name is Laplace. Okay, this scientist name is Laplace. Prior definition was developed by Laplace, though then it is called Laplace, otherwise it is called Laplace definition of probability. Okay, this is the main definition of probability. P of A is equal to m by n. Okay, so now I'm telling an important concept in this definition. So you can take you have to take if you conduct an experiment, there are n exhaustive events is there. Okay, then it is m of them are favorable and the rest of the events are unfavorable, right? So this is called n minus m are unfavorable events, right? Unfavorable events. So the definition of the probability of not occurrence of event A, that is called P of A bar, right? P of A bar is equal to, so favorable cases there, unfavorable cases n minus m divided by n. Okay, that is equal to 1 minus m by n is equal to 1 minus P of A. Mn is A. Therefore, P of A plus P of A bar is equal to 1. That means the probability of occurrence of an event A plus probability of not occurrence of event A is equal to 1. Otherwise, the probability of success and the probability of failure equal to 1. That is P of A plus P of A bar is equal to 1. This is one of the concept. And the limits of probability. To explain that concept, limits. So what are the limits of probability, prior probability limits? Okay, so what is that? By the definition of probability, P of A is equal to m by n. This is the definition of probability. It means P of A is equal to m by n. M means favorable cases and n is against cases. Okay, so m may take or 0 or less than n or equal to n. Okay, equal to n. So check it, the case 1, the first case, the case 1, if m equal to 0, that implies P of A is equal to m is 0 is equal to 0, right? And the case 2, if m is less than n, that implies m is less than n, then P of A is less than 1, right? Next case 3, and next one is case 3, if m equal to n, that implies P of A equal to 1. Therefore the P of A always lies in between 0 and 1. Therefore P of A always lies in between 0 and 1. That is 0 less than or equal to P of A is less than or equal to 1. This is the limits of probability. This is the limits of probability concept, right? This is the one of the definition of probability, that is called mathematical or law definition of probability. Okay, next one is the main important concept of the definition, the limitations or failures, or maybe so limitations of the definition. So what is that limitations? Next one is limitations of this definition. The one of the important limitation is the definition cannot be used for infinite large n, that is n tends to infinity. So if you take the tries or n tends to infinity, so number of tries is n tends to infinity, means n take large values. So this definition is failed. So this definition cannot be used for infinitely large n, right? This is one of the failure and limitation. And the second one is the events are not equally likely. The events are equally. That this definition is fails. This definition is fail when the events are not equally likely. The events are not equally likely. So these are two limitations there. Okay, this is the mathematical definition of probability history. And the second one, second definition, empirical definition, right? So what is that? Empirical or statistical. Empirical or statistical definition. Second, this is the second definition. What is that? Empirical or statistical definition, right? So what is that? Very simple. If a trial conducts, or if you take any random experiment, whatever maybe, if a trial conducts indefinitely large number of times, so that this is the one of the limitations of the mathematical definition of probability. That is, if n tends to infinity, the definition was failed. Okay, so and rectify this problem, so the trials are conducted and the n tends to infinity. I mean, trial conducts indefinitely large number of times, that is n tends to infinity. Okay, the n events are adjust to and mutually exclusive, and mutually exclusive and among them are favorable. To event A, favorable to an event A, favorable to an event A. Then the probability of occurrence of A is defined as probability of occurrence of A is equal to limit n tends to infinity m by n, and simply you can take the limit. Okay, this definition was developed by von Mises. What is that? Von Mises. The definition developed by von Mises. So the definition otherwise called von Mises definition of probability. That one definition of probability. What is the definition? If a trial conducts indefinitely large number of times, there is n tends to infinity, the n events are adjust to and mutually exclusive events, and among of them are favorable to an event A, and then the probability of occurrence of event A, that is P of A, is equal to 10 dash infinity m by n. This is the formula for empirical statistical definition of probability. So this technique was developed by von Mises, that it is otherwise called von Mises definition of probability. Right. Next, the third definition. Axiomatic. Third definition is called axiomatic approach to probability. Axiomatic approach to this is called axiomatic approach to probability. This is the third definition. So what is that? This definition was first developed by Kolmogorov, right? Kolmogorov definition of probability. Otherwise called Kolmogorov. So right, if a trial conducts, so there are n events. There are n events. The events are a1 comma a2 comma and so on n. If a trial conduct, the events are n events. The events are a1 a1 a2 and so on n. These are as usual adjust to and mutually exclusive. Adjust and mutually exclusive events. Okay, if a trial conduct, there are n events, a1 a2 and so on n. The events are adjust to and mutually exclusive. Okay, mutually exclusive. Right. Next one is right. And union I running from 1 to n ai, union I running from 1 to n ai is equal to, yes, this is an important point in the definition. Union I running 1 to n ai is equal to, that means a1 union a2 union and so on an is equal to s in sample space s. Okay, choose a function p such that the first one is called p of ai. So p of a is greater than or equal to 0 comma for all I running from 1 to and so on n. Okay, this definition, this one. Second one is p of es is equal to 1, and the third one is p of union I running from 1 to n ai is equal to summation I running from 1 to n ai. So p of a, p of a. P of a. Right? The first definition, the first statement remains, this is p of a greater than or equal to 0 is called a non-negative axiom. What is that? Non-negative axiom. Non-negative axiom, the axiom of non-negativity. And the second one is called certainty axiom. Certainty axiom. And third axiom is called additive axiom. This is called additive. There are three axioms. First axiom is called non-negative axiom, that there is p of a greater than or equal to 0. And second axiom is called certainty axiom, and this is called p of s is equal to 1. And third axiom is called additive axiom. Okay, p of union I running 1 to n a is equal to summation I running 1 to n p of a. This is the axiomatic approach to definition of probability. Okay, these are three definitions of probability. First one is called mathematical definition, and the second one is called statistical definition, and third one is called axiom of definitions of probability. Okay, this is the concept of various definitions of probability. Okay, next class we'll meet again another concept. Okay, have a nice day. Bye.